Hello, we're going to talk about accelerometers. So accelerometers are sensors that measure acceleration. So you can use these for detecting movement or the direction of gravity and strength of gravity. The particular sensor in this has this model number, but there are many, many sensors in this range that do similar types of things. In general, this particular sensor, it can measure plus or minus 2 Gs, 2 times the force of gravity, 4 times the force of gravity, or 8 times the force of gravity. And remember that gravity is 9.8 meters per second squared. And so we're able to specify the range that we want. So if you're measuring, things just on Earth, like a cell phone orientation or direction, you can use a smaller range, so plus or minus 2 Gs, and then you're more sensitive over that range. This particular device uses the I2C protocol. So why you might use this is for all sorts of applications. So tilt sensing. So because you're measuring the direction of gravity, you're able to tell if the device is slightly tilted or what direction it's going. Like if I was going to make a game where you're kind of balancing something. You can also use it to detect orientation. So this is essentially what's in your phone. And so when you turn your phone sideways and it switches to landscape mode, it's detecting the change, and that's what you can use this for. You can also use it for detecting small vibrations, or taps, or knocks, or thumps, things like that. You can use it for that. You can also, this is what's in a Wiimote, basically, or similar kinds of devices, like video game controllers that have sensitivity. You can detect if something is moving. You can also have this in some sort of electronic device where you need to take an action if the device is falling. So in detecting free fall, you can have a device that's able to detect if, let's say, your laptop is falling through the air, and so it can then maybe shut that device down or prevent operations that would damage if it hit the ground. Also, it's important to note that this sensor measures acceleration. It does not measure velocity. So remember that acceleration is a change. That's the derivative of velocity. It's a change in velocity. And so if you're moving at a constant speed and you're not accelerating, you're going to not detect the acceleration with this chip. So staying still versus moving at a constant speed, constant velocity, is going to generate the same signal, same output from the accelerometer. So just keep in mind, it's not measuring velocity, it is measuring the change in velocity. So that's an important consideration. So in this sensor, again, measuring acceleration in the XYZ direction. And so you can see that if you look at this particular chip, right, you can see that here it's telling you the orientation of X, Y, and Z. So obviously you can set the chip up to be oriented how you want, but it's measuring those particular directions. Due to gravity, we're always going to know essentially what orientation the device is, because at least one of these XYZ directions will be influenced by gravity, depending on whether it's how your phone is oriented or how your device is oriented. So you can kind of know what the orientation is by checking that. Now, there are a few similar kinds of sensors. There's many, many sensors, but there's a couple different types that you might also want to be aware of in terms of similar operation. So one is a gyroscope. So this is a similar kind of device, except what it's used for is measuring rotation. So in the X, Y, and Z direction, or pitch, roll, and yaw. So rather than measuring acceleration, it measures rotation. And so this is useful for guidance systems, for drones, autonomous vehicles, things like that, where you do need to actually measure rotation. And then there's another kind of device, which is more sophisticated, called an inertial measurement unit. Essentially, this is a similar kind of device which combines accelerometers and gyroscopes together. And so it gives you much more detailed measurements of the things you might be looking for, like orientation, position, velocity, things like that. This is much more useful for robotics, where you have many, many degrees of freedom, robotic arms, vehicles, things like that. So this is just a more sophisticated kind of combination device. Connecting this is very straightforward. It's I2C, so it's got clock and data, power and ground.